Okay, this section is about why suspension systems, especially rear suspension systems, can get to be very costly. If you're trying to do any fancy rear suspensions, what you'll end up having is here's your drive clutch, and you'll have some sort of drive belt system, chain, whatever, going over to your rear drive axle. Okay, and if you want to have your rear suspension be four-wheel independent suspension, then typically what you have to have is a bearing here and a bearing here. The output shaft will have to have a U-joint put on it. Then you'll put a shaft here and a U-joint on there. This shaft will be an adjustable shaft, so it can go in and out. We'll discuss that in a minute. And then you're going to have some sort of bearing that the suspension system is going to mount onto. And then off of that will be a hub that the wheel is mounted onto. And not to forget it all, we have a brake system mounted in here as well. So you can see there's a whole bunch of components that are adding up that are expensive, pricey. U-joints by themselves, for example, can go up to about $25. They're not cheap. So the alternative that you're going to be looking for, especially if you're making your own go-kart, is I would strongly suggest, how in the world are we going to get away from all this cost? That's the question. Okay, we're going to take a look at a typical rear suspension for a four-wheel independent suspension go-kart. Here the parallelogram system. It's joined together by some sort of hub, and then you have a bearing which would be fixed in place somehow into the hub section. The drive shaft will come through. There will be a U-joint, and then a U-joint which would be mounted to a shaft. As we discussed last time, this shaft has to slide into another shaft. In other words, it's adjustable. And another U-joint up here. Then you have your bearing, which is mounted here in the framework somehow, and then it goes over to your regular shafting. This would be your drive sprocket, and even a brake disc would be mounted there. The suspension, that's basically how the suspension would be set up, and then you'd have a hub that would be mounted on here. Typically the hub is mounted on with a bolt or a nut and then pinned in place. And then there's studs that stick out of the hub which mount onto the wheel. Now we can discuss later how the dynamics of the suspension work so that you actually get the best benefit from how the suspension is designed. This particular video is going to discuss the pitfalls of trailing arm suspensions. Trailing arm suspension there's two different ways. Here's a go-kart frame, for example. A trailing arm suspension would be one where it comes forward like that, and then say your wheel is mounted on this trailing arm. Another trailing arm would be, here's another go-kart frame, and the trailing arm comes off the center of the go-kart and bounces up and down that way. It would move up and down this way. This one moves up and down parallel to the frame. We're going to discuss this version first. Basically, if you take a look at the side of the frame, and this is the frame of the go-kart, you have your suspension which moves up and down, and it moves parallel with the go-kart, straight up and down this way. Now, from the surface, that appears to be a very good design. However, when the go-kart does a roll like this, the outside wheel tends to drop up and stay obviously parallel with the frame of the go-kart. Well, you can see that what's going to occur is that you're going to have the wrong side of the tire. You're going to have, here's an exaggerated version, you're going to be wanting, all the forces of the turning are going this way, and you're going to be grabbing the wrong side of the tire, and the tire will actually scrub under. It'll actually bend under. So how do you get that to not happen? Well, with this particular go-kart suspension system, that you can't really escape that. The best way you can escape that is to design it so that when your suspension goes up, it actually flexes a tire in a canted position, so that when the body rolls, that you actually grab the best part of the tire so that the force vectors are working in the best position. Best way to say this is that it's kind of like when a motorcycle is leaning, you want to have the forces not to scrub the tire under or bend it. Here's the best way to look at it. The tire tends to bend if you take a look at it. If you notice that the tire tends to bend, here's an exaggerated version, then you make it so that it bends in your favor. And that's typically how you design your suspension system, so that when it goes up and the body's doing a roll, that the suspension tends to be, this is an exaggerated view, dig in better, so your resultant load or your resultant forces are. In this video we're going to be discussing the pitfalls of a front suspension system, which is parallelogram, and how the wheels will end up having issues when the suspension is bounced up and down. Now if you don't have this, the rod which moves the suspension in line with this center line of this line of action for the suspension, what will end up happening, and you can't really see it in this view, but what will end up happening is that when this flexes up, the distance for this rod, as you can see, will become longer. Being longer, it will cause the tire, and here's the top view, it will cause the tire to rotate that way around. So in other words, when the suspension goes up, the tires will tend to rotate in that direction. When the suspension goes down, they'll tend to rotate on their pivot axis that way. Now the way to get around that, obviously, is to use the center line. You have to stay in the center line, and you have to understand where all this linkage lines up, so that when this parallelogram system moves up and down, this length doesn't change. You have to keep a particular eye on that. Now, that may take some doing. Also, with the way to actuate your steering, this is going to have to be adjusted, so when it moves in and out, there's going to be some variance in how this actually works.